Alright guys, sorry I gotta truncate this a little bit. Let's take a look at these. Which problem, by the way, let me get a little vote going on here. Which problem on here was the hardest one? Anybody? 3A? Anybody else have a vote for the hardest one? Does everybody agree on 3A? 2A? Alright. 3C, yeah. Yeah, the funny thing about 3C, you either remember it and it's easy as shit, or you don't remember it and it's hard as hell, right? So, yeah, alright, man. Okay, let's just look at this. This very first one is really important because the bread and butter of mathematics is solving equations. So in reality, we set up an equation that models the observations we make, and if we can solve it, we can then predict, for example, where a hurricane's going, if an earthquake's going to be a certain kind of earthquake that makes a tsunami, all this kind of shit. So mathematics, I made that equation up completely, right? I just made that shit up. In the real world, we make observations, we set up an equation that actually incorporates our observations, and then we can make predictions. Are you guys kind of with? So in class, we're not doing real shit yet. We'll do a little bit of real shit. So what's the very first step in that kind of problem? Beautiful. Because the whole idea with this problem is get your like terms together, right? And then it can kind of move x's on one side. But I can't get my like terms together if they're stuck. So let me ask you this. This is going to be a very strange question. Does anyone see a -4 in there anywhere? No, I don't see any -4. What I see is a 12. Yeah. So I can't add 4 because there isn't a -4. There isn't. It's just a 12 that some crazy person, me, broke apart. Yes. So I've got to put that shit back together so then I know what to actually move. Are you guys with me? So the very first thing you do with what's called a linear equation. Anyone know why it's called a linear equation?
Straight line.
All the variables have a what kind of power? What's the power on every variable in there?
1.
First power. So that's a linear equation. So I'm going to distribute wherever I can. So what am I distributing here? -3. Beautiful. So the 2x just comes to the right. Then I get -3x plus 12. And then here, what am I distributing? Good. So I get x, -9. Negative is crazy sauce. Sorry. Very strange noises happening. And then like terms here, what's 2x minus 3x?
Minus x.
Holy shit. And then what is x plus x? Holy shit. Okay. And is everybody with me? So this is coming back. And again, do not sit there and feel bad if you forgot some of this stuff. Maybe it's been a while. I know some of you guys haven't taken math for a few semesters. Some of you guys just took it last semester, but you're like, dude, there's a bit of time between then and now, so it leaks out the brain really quick. So just let it come back. Don't get on your own back about this. What's the next thing I want to do now? I want to get my x's on one side, my numbers on the other. It doesn't matter which side. So I would do this. I would add the x. Because what that does is it keeps my x's positive. Negatives are a good place for humans to make mistakes. I always like to say it that way, because humans, I have heard that humans make mistakes. So negatives and all that kind of shit, just, if you have a choice, don't let a negative show up. And of course, what's in the wrong place? That silly 9's in the wrong place, so to kill it, I better add 9, die. And of course, you can just see what that answer is, yes? 7, kick ass. So I saw a lot of 7s. That's awesome. This should not be a hard problem, but again, for some of us, it's been a little while, so let it kind of come back. Okay. What's different about 1b? The obvious immediate difference.
It's squared.
Yeah, it's got a power not 1. If you ever have an equation with a power that isn't 1 on one of your variables, you got to get it equal to 0 and then factor it. Yes? Does that sound familiar? Why do I have to do that shit? Because why could I solve part A? Because all my x stuff went into one term, yes? I got all my x shit and I got 3x. I got them all together. Can I do that in part B? What's x squared minus 3x? What is that? I love, there you go. The right answer is it's x squared minus 3x, man. What do you want from me? I can't get all my shit together in one term, so I have to have a different way to solve this. And the idea is, if I know two numbers multiplied by 0, what must be true? One of them must be 0. If I know two numbers multiplied by 10, is there anything definitive that must be true? No. One could be 2, the other one's 5. One could be 1, the other one's 10. One could be 20, the other one's 1/2. Holy shit, there's an infinite number of things it could be. So I've got to get it equal to 0. Because then when I factor, I know that one of them has to be 0. You guys with? So every process we do in mathematics is based on just what makes sense. It's not just shit we made up, believe it or not. Okay. So first thing, I want to get it equal to 0. So what do? Subtract 10. Now, if you remember anything about factoring, this is one of the easier forms, right? Because how do I make x squared? What do I put here and here? So the whole thing boils down to a number problem, a number puzzle. What two numbers multiply to be negative 10? Add to be negative 3. Positive 2, negative 5. And then you just say to yourself, okay, if this number is 0, the whole thing is 0. So what makes this 0? Negative 2. If this is 0, the whole thing's 0. So what makes this 0? Done. How many answers did we get? What was the degree of the problem?
2.
Hey, that's called the fundamental theorem of algebra. The degree of the problem tells you how many answers to expect. Crazy shit. Okay. You guys all with me? Sorry, somebody gave me one of these. I understand. You're like, This one, somebody identified as being one of the hard ones. The thing is, who remembers what a fractional power means? It's the same thing. Oh, yeah. As a root, yeah. So in this case, what root would it be? Cube root, because where are roots on plants? Most plants. Bottom. One year I had this. I always do this, and I'm like, I'm a geek too, so I can make fun. Excuse me, but the tubers have roots on. Like most plants, roots are on the bottom, correct? So the 3 is on the bottom. I'm sorry, I point there because I can see the problems. The 3 is on the bottom. That's the root. So what is the cube root of 8? What do you get when you cut 8 into 3 pieces multiplicatively? 2. Because 8 is 2 times 2 times 2. So 8 to the 1/3 power is 2. What is anything to the 0 power?
1.
Freaking 1. Good. Okay. I like it. Okay. And then part B, I had a lot of people ask me about part B. What does that based on? What is that problem really highlighting? Yeah, what are the order operations? Yeah, PEMDAS. What's it stand for? Please excuse my dumbass son. There it is. Please excuse my class came up with this. Please excuse my deficient algebra skills. That wasn't me. I didn't come up with that. What is it? So it's parentheses, exponents, blah, blah, blah. So real quick. I have seen teachers teach that multiplication comes before division. That is bullshit. They need to stop. They need to get to another career. Dear God. Right? The real way it should be written is like this. God, I talk a lot. We have no time. Please excuse my dumb ass. Okay. Parentheses definitely first. Exponents definitely second. Either one of these as they come. Either one of these as they come. And real quick, I want to point this out. What's the only number this problem says to divide by? Do you guys agree? The original problem, the only thing it wants you to divide by is 6. So if the first thing you do is multiply these, what are you divided by then? That's not fair. What the shit? So of course you don't multiply, but it's just whatever comes first. So what's the very first thing I do? Order operations. Parentheses. What's 10 minus 13? Holy shit. Okay. So you get 12 minus 4 times negative 3 squared divided by 6 times 4. What's the next thing? Exponent. So what's negative 3 squared?
9.
Good. Not negative 9, yes? The negative dies. Poor little dude. What is the very last thing I'm going to do? What's the very last number that gets a turn? 12. Because that's subtraction, which is the ass end of PEMDAS. Yes? I got a lot of stupid little jokes. I'm sorry. But now I got that whole chunk that's all on the same level. So you just do it as it comes. What is 4 times 9? Divided by 6. 6 times 4. So I get 12 minus 24. Yeah? 4 times 9 is 36. Divided by 6 is 6. Times 4 is 24. And what is 12 minus 24? Good. I got $12 and I owe you $24. I could pay you off and still owe you $12. So money is a good way to think about with signed numbers. And then finally, maybe I'll have time to show you that. Yeah, we'll see. This guy, and this is what I really wanted to focus on today, so I'm going to let go of something else I was going to try to do. Factoring is stupid important. Factoring is everywhere. So if it's been a while, if you need to refresh, I've got a factoring handout up in Canvas that explains all the different forms of factoring. So you can grab that. I can print one out for you if you need. Yes? Okay. Let's start with part B. How many terms does part B have? Because nobody said this one was hard.
2.
It's got 2 terms. So it could only be squares or cubes. Can I cut everything in half or cut everything in thirds? Half. So the x squared, 1x goes here, 1x goes there. What's 16 cut in half multiplicatively? Not additively. Multiplicatively, 4. Because how does 16 get made? When I multiply those things, right? When I FOIL it out? Do I have a middle term here? Are there 3 terms? Which means the middle term must have canceled, which means these have to be, yeah, good. Minus plus, plus minus. They have to be different signs. I love it. Is that coming back? Difference of squares is the thank God problem. Whatever God you like, the God of coffee, the flying spaghetti monster, whatever God you like. It's a thank God problem. You just thank your favorite deity. God of math shining down upon you, whatever the shit, yes? So when you see a difference of squares, you can cut everything in half, minus plus, you're done. Next. On the heels of that, we'll do this one, don't worry, I'm going to come back to him. This guy. That's obviously not a squares, but can I cut everything in thirds multiplicatively? Yes, because we just talked about 8, right? What is x cubed? X times x times x. What's 8? 2 times 2 times 2. So actually write that shit out. So I get x times x times x. 2 times 2 times 2. So here's how this works. And this is why people hate it. Because you just have to memorize how to kind of build this. So I'm going to have a little dude and a big dude. Little dude, big dude. This is just a little dude. Poor little dude. You can only fit one of each. 1x and 1, 2. And I'm going to put the same sign there was here. I'm going to put it here. If I put 1x there, how many have to go here? Because I have to end up with x cubed. What's have to go here so I make x cubed when I start to FOIL this thing out?
Square.
The other 2 x's, yes?
How'd you get the minus?
Oh, I'm sorry. My eyes can't see that. That's a plus. Okay. Should be the same sign there.
Oh, okay.
Thank you. So what should go here is the other 2 x's. So what should go back here is the other 2 2's. Do I get my x cubed?
Yes.
Do I get my 8?
Yes.
Yes, totally. So why do I have this extra space? Because don't I also get 2x squared? Did I want 2x squared? I really want this to make sense. Whatever we write here has to multiply back out to be this. Does this currently multiply that to be that? No, because don't I get extra shit? Don't I get 2x squared? Don't I also get 4x? So I need somebody to cancel that stuff out. Let me make my little joke. Has anybody ever seen Pulp Fiction? The movie. That's what I'm talking about. Remember the scene, back of the car, something horrible happens. They have to call somebody, the cleaner. I think it was the wolf. So they had to clean up all the stuff they didn't want in the back of the car. You with me? It wasn't a prereq to watch that movie. You're okay. But you should still see it. It's a really good movie. So the guy that goes here, now watch, what do we have so far? I had 3 of everything, correct? I put one of each there and 2 of each there. That only makes sense. That makes 3 total. And I got extra shit. So what's always going to work is Opposite sign, makes sense because it's supposed to cancel stuff. This times this. So see this 2x squared? Doesn't it cancel with this negative 2x squared? I like it. And see this 4x, doesn't it cancel with this negative 4x? Okay, maybe. So one of each, two of each, product in the middle. Let me write it down again because that looks like a football play there. Notice something about the signs. This is the same sign. This is the opposite sign. This is always positive. And what I love about that is it goes right along with that Pulp Fiction analogy because I had to use a lot of soap for the back of that. So if you've seen the movie, you know what I'm talking about. Okay. Let's do another one real quick. What time is it? Yeah, Jeff. All right. So what if I had 27w cubed minus 64? So obviously it's a cubes, but it's got two terms. I can cut everything in thirds, yes? What's 27? 3. What's w cubed? W. And what's 64? Not 8. I needed 3 pieces, 4. You guys with me? I can cut everything in thirds multiplicatively. So I got 3w. I got 4. I put my little dude and my big dude. There's the ass and the PEMDAS. All right. What goes in the little dude? It's just a poor little dude. So what goes in the little tiny dude? 1 3w and 1 4. What sign goes in the middle? Good, same sign. So that's 1 3w. So these two go here. What's that make? What goes here? What's 3w times 3w? 9w squared. Do you guys see how I get 27w cubed there? You see that? I get 27w cubed, yes? So you can kind of check yourself as you go. Right? Check yourself. What goes at the end here? I put 1 4 here, so what's got to go here? 16. So there I got my minus 64, yes? What sign is the middle dude going to be? Plus, so we can cancel out stuff. And it's always, whatever the hell's in the little dude, multiply. 3w times 4 is 12w. Shabam! You can never factor the big dude unless there's a GCF you forgot. Does this sound familiar to anybody? Is this coming back to anybody? Or you're like, I never understood this shit in the first place, so I don't know.
So you multiply, when you multiply it in the little dude, the sign doesn't matter?
This sign here must be the opposite of that one.
Oh, okay.
Why does that make sense? Because this guy's job is to cancel the other shit that I don't want.
So like it would be, because like 3w is negative 12, but since it's the opposite sign, it would be 12.
Yeah, you change the sign, and then you just multiply the 4 and the 3w.
Okay,
Yeah.
that makes sense.
I like it. Some of you guys look like you're smelling old cheese. You're like, All right. So last one. This guy. By the way, if I didn't make a big enough point of this, factoring is everywhere. If you're really bad with factoring, you want to focus on that immediately. Are you guys with me? There's a factoring handout up in Canvas. I think if I remember correctly, there's some problems there for you to do. Tutors can make problems up for you. You want to focus on factoring because it's going to be everywhere. Okay. What's the first step on this silly thing? Do you see if I took that 4 away that it's the same problem as the first one we did? Yes? But there's a 4 there. It's going to mess things up. It's going to mess this stuff up. So the very first thing I've got to do is I've got to take it into account. So I don't get numbers that multiply to negative 10 had to be negative 3. I get numbers that multiply to negative 40. add to be negative 3. Does that sound familiar? I know I saw a few of you guys doing that. This is either called the master product, this is called the AC method. I call it the surefire method. Because that's what it was called when I was taught it 3.7 billion years ago. What numbers multiply to be negative 40 and add to be negative 3?
Negative 8 and 5.
Negative 8 and 5. Did I turn that camera on, Denny?
It looks like it.
Thank God. What do you guys do after this? Did anybody get this step? Can you tell me what you did after this? You're like, dude, I didn't do that one. Okay.
I put those in place of the negative 3x.
So you rewrite the middle. Does everybody agree that negative 8x plus 5x is the same thing as negative 3x? Do you all agree with that? Did I change the problem? No. I just made it look different. And some of you guys are like, yay, Jeff, good job. You didn't do shit. Yay. All right, give me a The numbers I get from this process are the only two numbers that will make the grouping work for this, yes? There are 4 terms now. If I group these, what comes out of these first two?
4x.
4x. So I'm left with x minus 2. And what comes out of these two?
5.
5. So I'm left with x minus 2. How do I know I'm on the right track? I'm pushing it here with you guys. You're all like, dude, I hit my limit about 2 minutes ago. All right. I know I'm on the right track because these are the same. So I'm able to take them out. What does each term have? Each one of these terms has an x minus 2 in it. So let me take it out. What's left? 4x plus 5. Done. Now, if you have another way to do that, just show me, right? At some point. The one way I will not accept is to find these numbers and then divide by 4 and do some weird shit. It's called the bottoms-up method.
Wow.
I do not let people do that unless you can explain to me why it works. Otherwise, just do this. Okay. All right. I think that is plenty for the first day. So I appreciate you hanging with me on that last part. I'm going to post the video from the lecture today. Look at it again. If you have any questions, come see me. Otherwise, I'll see you guys tomorrow. We'll do it all. So, like, I didn't really say this, but today we did 1 5 factors. That section, you should be done with it by Wednesday. It's not late until you kind of turn it in now. You always have until the end.
Literally at midnight, I was like, oh, go take his cousin as a case, because I really don't recommend it to that.
Yeah,
You can't be telling me that the night before.
I should have just said, don't everybody give me everything on the day of the test.
Alright, I wasn't sure.
Give it to me and you get it done.
I did a presentation like this.